Well, hello there. Here's a quick video on finding a solution set for an equation when you're given a replacement set. So really, you're just seeing which values. What we're going to do is find which ordered pairs fit in an equation, which ones don't. So that's our goal. Find a solution set. I can find a solution set of an equation when given a replacement set. All right. So just to get us warmed up into that, I put this one on here, this problem on here, which is something we've done before. It's kind of a review, but it's also taking a look at what we're doing today, but in a more simple sense. Okay, it's something that you've done before, and this would be finding a solution for just a one variable equation. So this one we have one variable. Is 2 a solution for 2x plus 3 equals 8? Well, if you use the 2 and you look at the equation, there's one unknown in the equation, that's the x. So if you figure that out, that's where you're going to put the 2. You're going to substitute the 2 for x and see if the equation works out. So we'll do that. 2 times 2, because that's what we're replacing with, plus 3 equals 8. We'll simplify this. Remember, you do multiplication first. So that would be 4 plus 3 equals 8. And then we can do our addition, which is 4 plus 3, which is 7, equals 8. And if you look at that, is 7 equal to 8? No, it's not. So the answer would be no. 2 would not be a solution for this equation because it does not make the equation true. Okay, that's exactly what we're doing today, only we're going to be working with 2 variables. So to start us off, a couple terms you're going to need to know. 2 of the terms that are in the goal are right here. Finding, using a replacement set. So a replacement set is, very simply, a set of numbers from which replacements for a variable may be chosen. So you'll be given an equation. And we talked about sets recently. You'll be given a set, which with the fancy brackets, a set of ordered pairs. So maybe -1, 0. I'll say 1, 2, and 3, 4. With the fancy bracket, that's our set. We're going to take that replacement set and we're going to find which parts of that replacement set are part of the solution set. So that means the solution set would be the set of elements from the replacement set that make an open sentence, or in other words, I'll cross it out and say an equation true. Make an equation true. So maybe we'll plug these in, we'll find that just 2 of them are true. That would be your solution set. All right, we'll get to an example of that in a second. When I say things about a true sentence versus a false sentence, a true sentence is very simply just 2 things that are equal to each other. Like x is equal to x, that's the same thing. 6 equals 6. -15 equals -15. And I actually wanted to say equals there. Whereas a false statement, which is the ones that'll tell us it's not part of the solution set, false statements are 2 things that are not equal but are set equal to each other. So if you have an equal sign with, let's say, 6 equals -15, that's not true. That is not true, so it's a false statement. I'll use red because red is usually the negative color, like stop. Let's say 4 equals 1. No, that's not true. Those are false statements. 4 is not equal to 1. So we're going to be given something like this. Find the solution set for the equation. And given an equation, first of all, you have an equation, y equals 8 minus 3x, and you're given a replacement set. We have 4 values here, 4 ordered pairs. Which parts of that replacement set, we're trying to find which parts of that replacement set would make up the solution set. So to do that, we're going to follow these simple steps. 1. Replace the x in the equation with the first value of the ordered pair. Remember, the x is always the first value, so don't mix it around just because the x might be on the left side of the equation or on the right side of the equation. Replace the x with the first value of the ordered pair, and replace the y with the second value of the ordered pair. That's the main thing. If you can do that, if you're good at substituting in, you'll be able to figure this out. Then, solve the problem to see if you get a true statement. If the two sides are equal, the ordered pair works. That means it's a true statement. If the two are not equal, it doesn't. So only the true statements are the ones that are going to make up the solution set. Okay, so let's look at our example. We're going to first replace the x with the first value in the ordered pair, and then the y with the second value in the ordered pair. So we're going to take our equation, and we're going to look at our point 4, negative 4. That's our first one. Since 4 is the x, we're going to replace it with the x. And you can see right there. And negative 4, we're going to replace with the y. So this one will go right here, because the x was right there. This one will go right there, because the y was out in front. And now that you have it plugged in, it's all numbers. It's just you doing some math. Simplify things. Remember, order of operations. Do the multiplication first, which would be 12. And then you can do your subtraction. And you can see that would be 8 minus 12. 8 minus 12 is negative 4. We're not doing anything to the left side because we don't need to. That's just a number. We're trying to simplify the right side. And negative 4 equals negative 4. And obviously that is a true statement because negative 4 is equal to negative 4. Sorry. So that means we can take a look at our replacement set and say, all right, I know this one is good. Okay? Then take a look at the other ones. You do it all with the other, the other 3 ordered pairs. So you take a look at the second one, 8, 0. You have 8, 0. Plug them in. 8 goes in for the x, because that's the x. 0 goes in for the y, because that's the y. And then simplify, doing some math. Do your multiplication first. That'd be 0 equals 8 minus 24. And 8 minus 24 on the right side is negative 16. And that is a false statement. So I'm going to go and I'm going to cross this one out. That's not true. It's not going to be part of our solution set. Next. Take our next one. Plug in the x. Really, it doesn't matter because they're both 2. Plug them in for the variables. You get 2 equals 8 minus 3 times 2. Do your multiplication first. 3 times 2 is 6. 8 minus 2, or 6 is 2. So 2 equals 2. And that is a true statement. I will circle that, because that one is true, so that one's good. Last one, 3, 3. Plug it in. 3 equals 8 minus 3 times 3. Do your multiplication first. It'd be 8 minus 9 on the right side, which is negative 1. We know that 3 is not equal to negative 1. They're 2 different numbers. So this is a false statement. So I'm going to take my thing and I'm going to cross that out. Now, really, the hard part is done. All you have to do is take a look at the 2 that were correct, 2 that were true, put them into the fancy brackets to show it's a set, and that's your answer. That's the solution set. Just the 2 that were true. All right? And that is how you do that. So, take a look at the other 2 examples I have here. I have 2 of them. I have a solution set, or I have an equation, and I have a solution set for this number, example 2. Equation, or sorry, I have a replacement set, and I want you to find the solution. And then if you want a more challenging one, this is one that's actually not linear, but I still gave it to you because I want to see how you do with it. You're still plugging in for x and y, figuring out which ones are true, which ones are false. So that would be the true ones would be the solution set. So I'm going to quickly go through number 2. And you can follow along, and I would like you to try it on your own. If you can pause it and try it on your own, that'd be awesome. But I'm going to go through this real quickly. So I have my 4 points, 0 and 0.5, 4, 1, I'm just showing you how I set it up. 2, 0.75. And if I set it up this way, I usually don't make many errors. It's nice that way because it's organized. So this first one, look back at our steps. Replace the x with the first value and replace the y with the second value in the order pair. So the first value is 0, so we'll place the x with 0. So we have 3 times 0, and then replace the second value with the y, minus 8 times 0.5, or 1/2, equals negative 4. We'll do some simplifying on the left side. This cancels out because that's 0. Negative 8 times 1/2. So 1/2 of negative 8 would be negative 4. Equals negative 4. So that's true. So then this one would be part of our solution set. We know that already. I'll divide this off so we have some more room. All right, in blue here, the 4, 1. We'll replace 4 with the x and the 1 with the y. So 3 times 4 minus 8 times 1 equals negative 4. All right, and let's solve it. Let's simplify it. I mean, do your multiplication first. 3 times 4 is 12. I don't know why that keeps happening. 3 times 4 is 12. Minus 8 times 1, which is 8. Equals negative 4. 12 minus 8 is 4. And that is not equal to negative 4. Those are opposites. So this is a false statement. No good. Cross that out. It's not part of your solution set. Okay. Take some room here. We'll do this one in purple. 2 and 0.75. So we have 3 times 2 minus 8 times 0.75 equals negative 4. Now, do your multiplication first. So this is 6 minus 8 times 0.75. That would be 3/4 of 8. And if you can't do that in your head, use a calculator and multiply it out. 3/4 of 8 is 6. So 6 minus 6 equals negative 4. That would be 0 equals negative 4. That is also false. Cross that out. That's not part of our solution set. And then last, we'll use gray. All right, 2, 4. We've got 3 times, we're plugging 2 for the x, minus 8 times the y, which is 4, equals negative 4. Okay, so let's simplify to see if the left side is equal to negative 4. You have 6 again here, 3 times 2, minus 8 times 4. 8 times 4 is 32, minus 32 equals negative 4. 6 minus 32, that's going to be a negative number, so negative 26 equals negative 4. That's also false. So get that out of there. That means that our solution set for this one, the only one that is true, is 0 and 1/2 or 0.5. So the solution set, our answer, our solution set would be, with our fancy brackets here, just 0.0 and 0.5. And that's your answer. Again, if you'd like to try the challenge one, it is right there. That one we went through, you can go through on your own. I will give you a hint on number, let's see, I'll start you off with number 14, because everyone has to do number 14. So again, for number 14, it would be y equals 4x plus 1. You have your replacement set of 2, negative 1, 1, 5, 9, 2, and 0, 1. Lots of commas. There's our replacement set. You got to take each one break it down, find which ones are true. Alright, this one will be nice if you plug it in right. Remember, the first value is the x, so you put that in for the x. That means that it's y, and the second value is the y. So it'd be -1 equals 4 times 2 plus 1. So it'd be -1 equals 8 plus 1. -1 equals 9. False. Not good. Next one. We're plugging in y is going to be the 5, and the x is the 1. So equals 4 times 1 plus 1. 5 equals 4 plus 1. 5 equals 5. True statement. So this one's good. Next one. 2 equals 4 times 9 plus 1. 2 equals 36 plus 1. 2 equals 37. Not true. False statement. Cross that out. And then last one. 0 and 1. So you have the y is 1. So it's 1 equals 4 times 0 plus 1. 1 equals 0 plus 1. 1 equals 1. True statement. 1 is equal to 1. So that one's good. That means that our solution set for number 14. Solution set. Solution set. That was weird. Alright, solution set would be the 0.15 and the 0.01. That makes up our solution set, and that is your answer. So that's what you would do for the other parts in part 1. So if you're doing 14, 15, 16 for the basic, or if you're doing 14 and 18 and 19 for the advanced, same steps. Going to numbers 21, 22. This one you're given the domain, which is the x values. Make a t-chart and you find the range, find the y values. If you're down here, same thing. You're given the domain. You have to find the y values for 35 if you're doing that one. All right. So that's the video on finding a solution set. I hope it helps. Enjoy.